I'd like to give you a summary of what's going on with the Sn1 and Sn2 reactions. So with the Sn2 we've been talking about it being a one-step process, but one thing I haven't talked about are the stereochemical consequences of the Sn2 and Sn1 processes. So in the Sn2 case, what's going on is the nucleophile is coming in, joining on to this carbon at the same time as the other group is leaving, and that's what we're seeing there. Nucleophile comes in, joins, leaving group leaves, and it all happens at the same time. And what they're talking about here is an inversion of configuration. It's kind of like what happens when you go outside and it's windy and the umbrella turns inside out. So we end up getting a reversal of the stereochemistry from here. I'll show you a better picture of that in a minute. Now let's look at why the nucleophile has to come in and attack from the back. See, if it tries to attack here, there's not enough room. So it comes in, attacks from the back, and the nucleophile leaves, and the leaving group leaves at the same time as the nucleophile is attacking. Here we go again, see? Nucleophile comes in, joins on, leaving group leaves at the same time. Now let's say this is chiral. As I was saying earlier, the configuration actually gets inverted when the nucleophile attacks. So keep a close eye on what the reactant looks like and what the product looks like. So we only get one product from this reaction, but the stereochemistry is actually the reverse of what it was in the reactant. There's the reactant and there's your product. It's almost like they're a mirror image. They're not quite enantiomers because these two things aren't the same, but if you look at the general structure, they are mirror images of each other. And because these are three different things, it's going to turn out they're non-superimposable mirror images, so they are definitely going to be enantiomeric in nature. Alright, let's compare that to the Sn1 reaction. Now the Sn1 reaction is going to be a two-step process where the leaving group leaves first and then the nucleophile comes in a second step. Now since this is planar, it can come in from this side or it can come in from this side. So what that means is we can get two products, and these two products are truly enantiomeric. So they are stereoisomers of each other. So the Sn1 process will give you two products. Then these two products will be enantiomers. So to summarize what's happening with the Sn2 and Sn1 reactions, Sn2 reactions are one step concerted meaning happening at the same time. We get inversion of configuration at the reacting carbon, and we only get one product. The Sn1 process is a two-step reaction. We end up getting racemization of the reacting carbon, which means we get two enantiomeric products at the end of the reaction. That's two products instead of one product. Alright, to summarize that in another table here you go. Sn2 reactions are one step and they're concerted. They're favoured for strong nucleophiles. We get inversion of configuration. They're favoured for primary alkyl halides. They're second order. There's no intermediate in the reaction, and the reactions are favoured for aprotic solvents. For Sn1 reactions, they're two steps. The nucleophile strength is not generally important. The products are racemic, that is, we get two products that are enantiomers. They're favoured for tertiary alkyl halides. They're first order. There's a carbocation intermediate, and they're favoured for protic solvents.